Imagine throwing a baseball at a solid wall, only to watch it suddenly vanish and reappear on the other side without breaking the wall. It sounds impossible, like something out of a magic trick. But in the strange and fascinating world of quantum physics, events like this actually happen. The rules that govern our everyday lives, the ones that tell us objects can't be into places at once, or that things move in predictable ways, completely fall apart when we zoom in on the smallest particles in the universe. Quantum physics doesn't just bend the rules, it shatters them, leaving even the brightest scientists both amazed and deeply puzzled. One of the most bizarre ideas in quantum physics is something called superposition. In our normal experience, if you place a ball in a box, it's either on the left side or the right side, never both. But in the quantum world, tiny particles, like electrons, don't follow this logic. They can exist in multiple states at once, as if the ball were somehow on the left and the right side of the box simultaneously. This isn't just a wild guess, scientists had proven it in carefully controlled experiments. The particle remains in this ghostly state of possibilities until someone measures it, forcing it to choose a position. Until then, it's as if reality itself is undecided. Then there's the famous double-slit experiment, which reveals just how weird quantum behavior can be. If you fire tiny particles, like electrons, at a barrier with two narrow slits, you'd expect them to go through one slit or the other, creating two distinct bands on the other side, like bullets passing through two holes. But that's not what happens. Instead, the particles create an interference pattern, a series of light and dark bands, as if they're waves overlapping with themselves. This suggests that each electron passes through both slits at the same time, interfering with its own path. But it gets even stranger. If you set up a detector to watch which slit the electron actually goes through, the interference pattern disappears. The particles suddenly behave like normal little bullets again, going through one slit or the other. It's as if the electrons know they're being watched and change their behavior accordingly. This experiment has been repeated countless times, and the results always confirm that the mere act of observation affects reality at the quantum level. Another mind-blowing quantum phenomenon is entanglement. When two particles become entangled, their properties become linked, no matter how far apart they are. If you measure one, the other instantly reacts, even if it's on the other side of the universe. Einstein called this spooky action at a distance because it seems to break the cosmic speed limit, the speed of light. According to his theory of relativity, nothing can travel faster than light. Yet, entangled particles appear to communicate instantly, defying this rule. Scientists have conducted experiments where entangled particles were separated by hundreds of miles, and the results always show this eerie connection. This leads to one of the biggest mysteries in quantum physics. Does reality even exist when we're not looking? Some interpretations suggest that particles don't have definite properties until they're measured. Before observation, they exist in a blur of probabilities, a concept known as the observer effect. This idea has sparked wild philosophical debates. If a tree falls in a forest with no one around, does it make a sound? In quantum terms, we might ask, does the moon exist when nobody's looking at it? Some theories say no, that reality only collapses into a definite state when observed. Of course, this raises another question. Why don't we see these quantum effects in our daily lives? Why don't people or baseballs suddenly teleport through walls or exist in multiple places at once? The answer lies in something called decoherence. When quantum systems interact with their surroundings, their molecules, light, heat, their strange behaviors get washed out, leaving behind the familiar, predictable physics we know. Quantum weirdness thrives in isolation, but in the noisy, messy world we live in, it's quickly drowned out. Yet, scientists are finding ways to harness these bizarre quantum properties. Quantum computers, for example, rely on superposition and entanglement to perform calculations at speeds impossible for ordinary computers. Cryptographers are exploring unbreakable quantum encryption, and researchers are even testing quantum teleportation, not of objects, but of information. The more we learn about quantum physics, the more we realize how much it challenges our understanding of reality. So the next time you drop a ball and it falls predictably to the ground, remember, down at the quantum level, the rules are completely different. Particles can be in two places at once, communicate instantaneously across vast distances, and even change their behavior just because we're watching. Quantum physics forces us to question everything we think we know about the universe. It tells us that reality is far stranger, far more mysterious, than our common sense could ever imagine. And the most exciting part, we've only just begun to uncover its secrets.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.